In part 2 of this chapter, we covered how to redirect all traffic between EPGs to a firewall, using unmanaged service graphs. However, there may be scenarios where we do not want to redirect all traffic to the Layer 4 Layer 7 device, but just a subset of it. And this is where policy-based redirection, or PBR, comes in. As shown in this diagram, without PBR, ACI will redirect all traffic between EPGs to your next generation firewall, which would potentially create a bottleneck. In our case, not all traffic needs a stateful inspection. Therefore, if we take a look at the example shown, having HTTP and ICMP sent to such firewall may be a waste of resources which is unnecessary. If we use PBR instead, we may tell ACI to only redirect HTTP traffic to the firewall, but not ICMP traffic. With this, ACI can leverage Layer 1, Layer 2, and Layer 3 policy-based redirection, where you can define which traffic should be sent to the L4, L7 device as part of a service graph and which traffic should be routed by the fabric instead, avoiding bottlenecks and improving network overall performance. With PBR, you can also increase resiliency for multiple sites and pods in a seamless way, using features like symmetric PBR, which we will cover in Module 5, which selectively redirects traffic to different appliances when needed. The main 4 steps you just learned to configure a service graph stay pretty much the same when using PBR. However, there are a few minor changes. In this scenario, we want to communicate 2 servers in 2 different EPGs and bridge domains over our ACI fabric. We will configure PBR so that only SSH traffic is redirected to the firewall, while ICMP traffic will be routed by the ACI fabric directly. Our firewall will be running in 2-arm routed mode, and we'll be using 192.168 IP addresses for both the client and the server-facing sites, which do not belong to the same subnets configured in the bridge domains, as you can see. Let's go into APIC and configure this scenario then. We will first create our Layer 4 Layer 7 device in unmanaged mode, just as you know it, by adding a name to it, selecting it as a firewall service, and specifying it as a virtual firewall. We'll select our VMM domain and choose our firewall VM, as we already know, to configure it as a concrete device. Then, we will specify the VM adapters for the client and server side. In this case, I will use adapter 1 and 2, which will map to Gig 1 and Gig 2 inside the firewall operating system. Then, we will create our logical device interfaces and map them to our concrete device ones, as we learned before. So far, everything looks the same, as you can see. Next, we will create our service graph template just as we know it. The main difference here is that we will check the route redirect option and hit submit. We could then go to the application profile section and associate our Layer 4 Layer 7 service graph just as we know it, but I will show you another way of doing the same thing in this video. This time, I will go to our recently created template, I will right-click on it, and then I'll select Apply Layer 4 Layer 7 Service Graph Template. In this case, I will specify my consumer and provider EPG right here, and I will create a new contract called SSH PBR. I will include my SSH rule, which will include port 22 on the destination port range. I will now hit Next, and just as I did before, now I have to map the right bridge domain to the corresponding firewall service interface. However, before I do that, I will click on the redirect policy option this time, where I will create a redirect policy. This policy will be used for traffic flowing from the client to the server, and I want to make sure that all SSH traffic matching the contract is redirected to the client-facing firewall interface, which has a 192.168.1.254 IP address. In addition to its IP, I will also need the interface MAC address. So I will run a show interface command on the firewall to get the Gig 1 interface MAC address. I'll copy that value and paste it there. And we're done. After that, and as I mentioned initially, I will have to associate my firewall service interface, which in this case is the client 1, making sure it matches the right bridge domain. But we are not done, because in our case, we also want the returning SSH traffic to be sent to the firewall as well. Therefore, I will create a PBR policy for the traffic flowing from the server back to the client, which will be sent to the other firewall interface, which has an IP address of 192.168.2.254. I will also get its MAC address, hit submit, and make sure my bridge domain matches the right firewall service interface. And I'm done. If we now take a look at each EPG, we can see that they both have the SSH PBR contract we just configured applied to them. However, as part of our requirement, we also said we wanted ICMP traffic to be allowed and routed directly by our ACI fabric without PBR. Therefore, all I have to do is go to my existing SSH PBR contract and add a subject to it. I will add a name to the subject, and what will be different this time is that I will not associate this subject, which is made specifically for ICMP traffic, to a service graph. I will finish my configuration by matching ICMP traffic as part of the subject rules, and I'll hit submit. If we now go to our firewall VM, we can see that both network adapters already have the shadow EPGs automatically assigned as expected, and if we bring the consoles from both client and server VMs, we can see that the client VM has a 4442 IP address and the server VM has a 5552 IP address configured. Let's try to ping the server VM from the client. And it works. This traffic is going straight through the fabric without redirection to the firewall. We can verify such behavior by going to our firewall and shutting down one of its interfaces. As you can see, our ping still works, which confirms that ICMP traffic is being routed directly by the ACI fabric. Now, if we try to SSH to the server VM, we can see that it does not work as expected, since that traffic is being redirected and our firewall interface is currently shut down, as you remember. Let's go ahead and bring that interface back up. And as you can see, we can now successfully SSH into the server, proving that our policy-based redirection configuration is working. Another feature you would lose if you do not deploy service graphs is copy services. This is very helpful since you can copy traffic between EPGs even coming from multiple switches without using span sessions and without any encapsulation or headers added. After taking a look at how service graphs in unmanaged mode work, it is important to mention that this is by far the most popular implementation option. However, application-based integration for Layer 4 Layer 7 services is also gaining popularity. We will cover app-based integrations in further detail in Chapter 4 of this module, where we will deploy an app on top of APIC or the Nexus dashboard to consolidate both automated stitching and Layer 4 Layer 7 services configurations from vendors such as F5, as well as many others, providing you with multiple options to integrate your Layer 4 Layer 7 services directly on top of ACI. Finally, you may be wondering, what changes if I use Cloud ACI and I want to integrate L4 L7 services there? Well, not much. You will still need to use service graphs to implement your Layer 4 Layer 7 services just as you learned. However, the main difference is that in the cloud, ACI will not only redirect traffic to the Layer 4 Layer 7 service, such as a load balancer, but it also creates and configures such service automatically for you. We will cover how to configure Layer 4 Layer 7 services using Cloud ACI on AWS and Azure in Chapter 3 of this module, so stay tuned. With all this, you may end up having multiple sites and clouds which may need security and balancing services to provide higher availability. And the end goal is to provide those services in a consistent and centralized way across all of them. ACI and its services can be further integrated into the Nexus dashboard, as we will cover in Module 5, which provides a normalized multi-cloud and multi-site operational model which can distribute firewall and load balancer services to achieve higher levels of resiliency and high availability. As a summary, ACI can automate Layer 4 Layer 7 services stitching for Cisco and non-Cisco vendors, and integrate management and configuration through service graphs and API-based integrations, which can accelerate time to deployment, service chaining, and performance in order to avoid potential issues and bottlenecks. This allows us to increase resiliency as part of our designs, following a consistent policy anywhere, and allowing us to scale to multiple data centers, sites, or even clouds under a single operational model.
ACI provides you with a better, simpler, and secure network, any size, anywhere, and on any cloud. If you want to learn more about other common tasks and how ACI radically simplifies network provisioning and operations, please watch the rest of the videos in this series. Thanks for watching.